Well, hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says count distinct elements in every window. The problem goes we are given an array ARR and a number k. Find a count of distinct elements in every window of size k in the array. So, such is an array of size 4, and we are provided with a window which is 1, 2, 1, 3. Now here the count of distinct element is 3 so far. Now we go ahead, slide the window, and we have 2, 1, 3 and 4. So this is what the gist of problem is. We have 4 distinct elements, 3, 4, 4, 3 likewise. So, and we wanted to return that. So far so good. If you have been following this series, you know pretty much very well. If not, it's a high time to give it a shot to the previous problems. You can see the previous problems over here. It follows the same pattern over within the previous problems as well. Now we have to other these complexities, and it's pretty much simple. In an ideal brute force solution, you would run a loop of n into k, but we don't want it to do that. We would do a better solution. We would go ahead, we would store or the counts, and this would be required for getting distinct numbers for that window. Now we also need to know how we wanted to slide the window. Slide the window, and ultimately we want to return the result array. It's an array list. Okay, cool. So I would quickly go ahead and have an array list. That would be the thing which we would be returning. Result is equal to new array list, and we would be returning the result. Now things come out storing the count. How we would be going to store the count? Can we use hash set? Yeah, we can use hash set, but we don't know the count how to we map. So the better thing is to use a map. Map from integer to integer, which I will say map new hash map. And what it would be mapping? Yeah, that's a good question. It will be mapping a number to its frequency. So every time we slide a window, we need to adjust the map and associated frequency. So I'll tell for int I is equal to 0, I is less than k I plus plus. It is the initial time we are setting up the setting up the window. Initial setup. So how would we going to do this? We would be taking a map dot put what we are putting a of I with its count. So map dot get or default a of I comma 0 plus 1. So if we have a number, get that, else 0 and plus 1 to that number which we have got. Once we are here, we are sure that the initial setup is done, and I can freely move ahead to go from k to the end of array. Now within this, what are we going to do ahead? We initially have the array stored with us, so check for the array repetitions. Now I'm going to check for the repetitions. How would I go ahead and check the repetitions? That's a good question. I'll go ahead and check the repetitions by int repetitions is equal to map dot size. So size would give me how many distinct numbers I have, and this size I would be storing into the result dot add repetitions. Now it's time to remove the last and add the new. remove the old, add the new. What is the old thing? Old thing is nothing but int old. I'll write old is nothing but a of I minus k, and new new is a keyword, I cannot use that, right? N is equal to a of I minus a of I. That's okay. Old item I'll say, and new item, at least I can use new item. New item is not a keyword. Cool. How do I remove this? I'll check that. Hey, map dot get old item. If the size is 1, or just go ahead and delete it. Okay, map dot remove old item, else map dot put old item, map dot get old item -1. Cool. Same with the new one, but new one I don't want it to remove, I just wanted to add. Map dot put new item, map dot get or default new item 0 plus 1. So simple. So if you, for the new item, if you have new item, then you can give the count, else give 0, and I will add 1 to it. That is good, and this will run so far. For the last element, I need to do something. For the last element, for the last window, I need to add that within rest.add map.size. Why I am doing so? Because it will run for all the numbers, you see, but for the last number where I is equal to a dot length minus 1, it will add here, but and it will execute these lines, but it will never add, and it will end the for loop right here. So to add this, I am explicitly saying that hey compiler, go ahead and add. So let me compile this. It's compiled successfully, good for that. Let me try to submit this one, and yes, it is submitted successfully with the rest of all test case passing. So this was a classic example of having a sliding window with hash maps. So it has been asked in these companies, and I hope you understood the solution very well. For more such content, click the video on your right, and I'll see you in the next one.